Conventional fans have blades, and the problem with blades is that each blade chops up the air into a sort of wedge-shaped bit of air. And so coming towards you from the fan, you have this series of wedge-shaped blocks, and they buffet your face. They're also extremely difficult to clean. Just imagine having to take this thing to bits and clean all this, clean the fan blades and clean that. They also rely on this device here to clamp them to get them at the right angle. And you tighten it up and then the thing flops forward. So we've solved the problem of the buffeting by having no blades. The air comes out smoothly from this gap here and blows in a clear stream towards you. When we were developing the Airblade hand dryer, we had air coming out of this very narrow slot at about 400 miles an hour. And we noticed an extraordinary thing, that air was being drawn in from around the slot at tremendous pace and joining in from behind the air blade. We further analysed this phenomenon of entrained air on CFD and wondered if we could make a fan using the principle of entrained air. So here we've got a cutaway through the air multiplier. The air comes in at the bottom, goes through the mixed flow turbine and up into the loop at the top. Now the air comes out of this slot here and it comes down over this curved surface and down this ramp and off here. Now as it goes round that curved surface here, it hugs the shape and it's drawing air in like that. And as it shoots off the end here, it creates a negative pressure here and a huge amount more air is drawn in from the surrounding air. What actually happens is that we're multiplying the original airflow about 15 or 16 times. And you get a very clean, unobstructed and smooth flow of air. It's not chopped up as you get with blades. And also, because there's no blades, it's very easy to clean. You simply wipe it. And also, it's extremely safe. I can switch it on and quite happily put my head through it, which you couldn't do with an ordinary fan. It's also very easy to adjust the angle, and that's because this arc here is described around the center of gravity of the motor. So it stays wherever I put it. It's very simple to do. And the fact that the motor's down here makes it very stable. The other fans have the motor up here, which makes them top heavy. Ours is bottom heavy, so it's very stable and has a low center of gravity. And it has a dimmer switch to control the airflow, so you can adjust it to any setting that you want. And it has oscillation.